Why do drainage basins form fractal shapes? Imagine looking at a river system from above and noticing how the waterways branch out in complex patterns. These shapes are not random. They follow a fascinating natural design. When scientists study these patterns, they find that drainage basins often look like fractals. Fractals are shapes that repeat their pattern at different sizes and scales. This means that small tributaries look similar to larger rivers, creating a self-similar pattern across the entire basin. The reason for this repeating pattern is how water moves through the landscape. When rain falls, water flows downhill, eroding soil and rocks along its path. Over time, this erosion forms channels and tributaries that branch out in a hierarchical way. These branches split and resplit, creating a network that looks similar no matter how much you zoom in or out. This process is influenced by the terrain's slope, the type of soil and rock, and the underlying geology. All these factors shape the way water channels develop and grow. Fractal geometry helps us understand these complex shapes because it describes how the pattern repeats at different scales. Scientists measure how much space the river network fills within a basin using something called the fractal dimension. Most natural river networks have a fractal dimension between 1.7 and 1.9. A higher number means a more intricate and space-filling pattern, with lots of tiny tributaries branching out everywhere. Several factors contribute to the fractal shape of drainage basins. First, the natural processes of erosion and sediment transport constantly carve new channels and deepen existing ones. Second, the self-similarity occurs because smaller parts of the basin have similar branching structures to the whole system. Third, the terrain's features, like hills and valleys, influence how water flows and where tributaries form. Tectonic activity can also change the landscape, creating new paths for water to follow. Mathematical laws, such as Horton's laws, describe how the number and length of streams change across the network. These laws support the idea that river systems follow predictable patterns, which are inherently fractal. Understanding this helps in mapping watersheds, predicting floods, and managing ecosystems. It allows scientists to model how water and sediments move through landscapes more accurately. In essence, drainage basins form fractal shapes because the natural forces that shape rivers, erosion, geology, and water flow, create branching patterns that repeat at every scale. This self-similar structure is a key feature of how water systems develop and evolve over time.